We begin with a simple experiment that demonstrates a phenomenon called diffraction. You can imagine a wave of something traveling through a medium and reaching a barrier with a single opening. For example, light travels as a wave, and this experiment can be devised to work with a beam of light with a specific wavelength to pass through a very narrow aperture. Part of the wave will continue through the opening, and it will spread out beyond the barrier. The spreading out beyond the aperture is what we call diffraction. We can conduct experiments with the wave by changing its wavelength, the distance between two adjacent peaks in the wave, or changing the length of the opening of the barrier. It turns out there's a relationship between the wavelength, lambda, and the opening length, let's call it L, such that the ratio lambda divided by L determines the amount of spreading of the diffracted wave. If the ratio is large, meaning that the wavelength is large relative to the size of the opening, then the slit is considered relatively narrow for the wave. This means the wave will spread out very widely beyond the aperture. However, if the ratio is small, meaning the opening is large relative to the wavelength of the wave, then the diffracted wave is narrow and doesn't spread widely.